Hi grade 12 learners, welcome back to Maths Plus with Armien. In this video here, I'm going to show you how you can solve cubic or quadratic or simultaneous linear equations using a Casio calculator FX-82ZA Plus, or I'll also show those who have the FX-82ZA Plus as well. Before we actually start solving cubic equations using your calculator, let's look at a few, let's understand cubic equations. There we have a general form of a cubic equation, ax cubed plus bx squared plus cx plus d, and there we have a coefficient of a and a coefficient of b and a coefficient of c and a coefficient of d. This will be a cubic, but a should never be a zero. Because if a is 0, it won't be cubic anymore. We could have the b 0, we could have the c 0, we could have the d 0. Let's look at the simplest case. The simplest case is where the a value is 1. In other words, I have 1x cubed, as we have with this example here. Now, what will the factors of a cubic expression like this be? What is this d? D is a constant. That's a constant value. And that's the one that we have to concentrate on. So there'll be at most 3 factors. So it will be x minus the 1 root, x minus the second root, or x minus the third root. But alpha times beta times theta should give me, what should that product give me? That's right, it should give me d. So d will actually be the product of these 3 roots here. Then the next option is where a is not a 1. In other words, I can have a value like a 2 or a 3 or a negative 3 or a 5. For example, 2x cubed plus 3x squared plus 4x plus 5. What will the factors of such a cubic expression be? So this a here, because it's not 1, is going to play a role. How many factors should there be? At most 3. So I'll have x minus the 1 root, x minus the other root, but because I have an ax, one of the factors here would be ax, because ax times x will be ax cubed. But the same way, alpha times beta times theta, that should still give me a d. So that is the 2 types of cubic equations that we will generally work with. Now let's see what we're going to do if we use our Casio FX-82ZA. Right, this particular calculator is approved, so you're allowed to use it in the examination. But before we start, let's look at the factors. If x minus a is a factor of this expression, then it means if I substitute a in place of the x, instead of fx, I calculate fa, and if the fa's value ends up as a 0, then it will be a factor. So I'll only get a factor if I have x minus 2. In other words, if I work out f2, and if f2 results in a 0, then I know that x minus 2 is a factor. The same way, if I substitute and I end up with a 0, then if I substituted a, it means x minus a is a factor of fx. If I had a 3, it means x minus 3 is a factor of fx. Or if I have a negative 2, it means x plus 2 is a factor of fx. That's what you're going to use here. Now, to show whether x plus 1 or x plus 2 are factors, we can use the remainder theorem. So if I have x plus 1 and I equate it to 0, that gives me x equal to negative 1. So let's work out the function value of f negative 1. F negative 1, you go to your calculator and you do that, you enter that into calculator and you calculate it. You don't need to do it mentally. And this answer is 10. Because the answer is not a 0, I now can deduce that x plus 1 is not a factor. Let's look at the other one. X plus 2 means x is equal to negative 2. So let's work out f of negative 2. So I will put a negative 2 wherever there's a x, and that's what I do. So then you substitute, go to and be careful how you do that. Don't leave out the cube and the square. And this one, if we calculate it, it ends up exactly 0. So when this function value is 0, it means if I substituted -2, it means x plus 2 is a factor. Let's say I substituted 1 and it gives me a 0. That would mean that x -1 would be a factor. Or let's say I put in a -3. That would mean x plus 3 would be a factor again. Before we actually start using the calculator, let's look at the cubic function and look at the possible factors for a cubic function. Here we have a cubic expression, x cubed minus 3x squared minus 6x plus 8. So the factors here will depend on the constant value, this case 8. So if I look at this here, I see that my possible factors of 8 are 1, 2, 4, 8, or the positive or negative, positive or negative, positive or negative, positive or negative. Right? So, but because this is cubic, I need 3 of these to make a 8. So we have different combinations there. Similarly, if I take this one, x cubed minus 2x squared minus 9x plus 18, factors of 18, what are the factors of 18? That's right, those are quite a lot of factors of 18. You can either have the positive one or the negative one, and similarly positive 6 and negative 6. But 3 of them, product of 3 of them should make 18. So you have many combinations there. Can you try one? Let's see. If I say 1 times 2, so the third one will have to be a 9. Or if I say 2 times 3, which is 6, then I have to take another 3. So it will be 2 times 3 times. So you need to have combinations to make a 18. Let's look at this one. There we have 12. So I can have, what are the factors of 12? Those are the factors of 12. But because I have a coefficient of 2, I can also have roots that could be half and 3 over 2. How do we get a half? 1 over 2. 3 over 2. I won't take 2 over 2 because 2 over 2 will give me a whole number. I won't take 4 over 2 because it will give me a whole number. Similarly with this one tells me that I will also get, because I have 3, I expect thirds also as possible factors there. So it will be 1, 3, 5 and 15. Because I have 3, I can have 1/3. I won't take 3/3 because 3/3 is not going to be, it's going to be a whole number. Then I can take 5/3. Let's look at our first example using Casio FX-82ZA. This is the Casio FX-82ZA. Solve for x. Fx is equal to x cubed minus 3x squared minus 6x plus 8 equal to 0. Okay. First of all, what's the most important thing? Remember, the calculator must be switched on. Step 1, let's select mode. After selecting mode, you will have to make a selection. Choose 5 equation, and then after choosing 5, you get another selection. Then you take the one right at the bottom, that's number 4, and you can see there's ax cubed, there's the cubic expression. You select 4, and then you'll see a display like this will appearing when you have 4 values that need to be entered. A, B, and a C, and a D. Because it's cubic, there'll be 4 values that needs to be entered. The A is 1, the B is -3, the C is -6, and the D is 8, like we had in our quadratic equation. So, enter equal, and now you have to enter a 1 and an equal. Then you enter a -3 and an equal. Enter a -6 and an equal. Enter a 8 and an equal. Okay, and then you will see your display there would then be filled with a 1, a -3, a -6, and a 8. Now, before we go further with the calculator, I just want you to prepare a template. Remember, you don't hand in your calculator. This you can't hand in. You can't take a screenshot and then add it to your question paper. So you actually have to write down. Remember, we want to factorize. As we said, there are at most 3 factors. So it will be x minus the root, x minus another root, x minus the other root. So now let's see. Then we press an equal. And then pressing the equal there, you'll get a display. And that's what you'll see on display. But the actual display would look like that. You see x1 and a -2. So that means that f of -2 gave you an output of 0. right? So the function value there is 0. So that's one. So one of your roots there would be -2. Therefore x, and because you have a -2, the factor is x plus 2. We enter equal again, we get another display, right? That will be x24. I don't have it here. So that means f4 is 0. In other words, you have a root of 4, but the factor is x -4. Press the equal again, you'll get the third value. Remember we said we'll get 3, and that tells you f1 is 0 again. And if f1 is 0, remember from the main factor theorem, we have x minus 1 would be a factor. And there you get your three roots, x -2, x positive 4, and x equal to 1. Example. Okay, in this one here, I'm taking one with a 2 there. So what are the factors of 6? Could be 1 and 2 and 3 and 6. But because I have a 2, I can get some fractions. I can get 1 over 2. I can get 3 over 2. So let's write down what your factors are going to look like. It will be an x and an x. You know where the 2x come from? Yes, because I have a 2 there. If I had 3x, I would have a 3 in my third bracket. If I have a 5, I'll have a 5 there. So let's just go to the calculator now. After you've made your selection and you entered your A, B, your first display, just go to the display now. So it will display x1 -3. That means f -3 is 0. If I populate my factor there, it becomes x plus 3. You enter equal, you get your second display. That means f2 is 0. So I enter that, I get -2. And now you enter your third one, and here you see comma 5, or some calculators will write down a half. Remember, we expected the fraction. So one of them, if you don't get a fraction here, you definitely did something wrong. One of them will have to be halves. Either 1/2 or 3/2 or 5/2, in this case 1/2 or 3/2. Now how do I put this in here? That means f over half. Now remember, if you have a negative, you put in a positive. If you have a positive, you put in a negative. So there I've got positive a half, so I put -1. And you see that 2 already has the 2 there. There's the 2. So this is 2x minus 1 is equal to 0. And then you can just write down your three roots. X equal to -3, x equal to 2, and x equal to 0, 5 or a half. Excuse me. Let's look at another example. This one is going to be quite simple. Why? Because I won't have fractions here. You shouldn't get any fraction outputs here. So what are the factors of 20? It could be a 1 or a 2 or a 4 or a 5 or a 10 or a 20. Okay. So let's have the template. There's our three factors. Let's see what we get here. First one, display gives me negative, so that means f -2. So what do I put in the factor there? That's right, x plus 2. I enter another one, I get 5. So I get f5 is 0, therefore x -5. And I press and I don't get another one. But I expected a third root. There needs to be a third one. Now what does this mean? What this means is that, you know, the calculator tells you -2 works and 5. So one of them will be duplicated. Is it going to be the 5 or the 2? Let's say I have two 5s. 5 times 5 times 2, will it give me 20? No, so it can't be a double 5. So it will be another -2. So I'll use a positive 2 there. Okay? So you can see in this case, one of your roots is duplicated. So the calculator won't give you three outputs if one of them is exactly the same. So the only two roots are x equal to -2, which is duplicated, and the other one is x equal to 5. So do watch out for this. When you have that, don't panic. It is, remember we said you can have 3 different roots, or you can have 2 roots. We'll also see another. Let's look at this one. Let's say you go to mode, you enter your A and your B and your C, and now you're ready to get your display. So the first display is x1 is 6. That means x -6. I press my equal, and now I get something strange there. x2, and there's an I there. Now what does that mean? That I means it's an imaginary. In other words, it's a non-real. So you won't get any other roots. So this cubic here only has one real root. It only cuts the x-axis at one place. The other two roots are non-real, and don't bother with that particular one there, right? Because these values you won't be able to plot them on the x-axis. They're non-real. So that's x is 6. We can actually find so only f6 equal to 0 that works. And actually the other one here is a quadratic expression, but it will have non-real roots. Remember you gave you x cubed, so that's x times x squared gives you x cubed. There you have a negative 12, so negative 6 times what? Negative 6 times 2, so that's where the 2 comes from. Now where did I get this x from here? You see that's negative 6x squared. And how many squares do you have there? Negative 5. So what must you use with a negative 6 to make it a negative 5? You need a positive 1. Therefore it's positive 1 that I insert there. Now I would like you to try these 3 examples and see whether you can use your calculator. It should be very simple. You know what you enter, get your display, and always write down the template, and then you write down if F1 works, you put 0, right? So the calculator only tells you the ones that give you an output of 0, only because it's going to factorize it. And let's get those 3 and let's see what your result. Okay, now let's say we can actually use this, the calculator to actually solve quadratic equations. How do we normally solve quadratic equations? That's right, we use factorization. If that's a little bit awkward, or it's not possible for you to factorize it easily, you can use your quadratic equation. But now we can also use our Casio FX-991. See how we do that? Go to mode, we choose equation, and then from the equations we choose equation type 3. So you enter 3, and that's the display that you'll get there. You now get a display with 3 values. That's the A, there's the B, and there's the C, the same way. So 5 equal, then 7 equal, negative 6 equal. So that is populated. I now just write down there are going to be 2 factors. I have an x, but because I have 5x, one of them should be 5x. So it's x and 5x. Then let's enter equal, and now I get a display. There's your display, right? Negative 2, that means f negative 2 was 0. And if I have a negative 2, my factor will be x plus 2. I enter the equal again, I get my second root, and there I get 3/5. See, I'm not surprised to get fifths because I had a coefficient of 5, 3 over 5. And you see that 5 is already the 5 there. That's positive 3/5, so I need, that's right, negative 3 there. And then you get x equal to negative 2 and x equal to 3/5. So you can see you can easily just use your calculator. And I suggest when you have that and they don't restrict you, just use your this function. Also with this calculator, which you're going to use in calculus a lot, is solving simultaneous linear equations. And with the Casio FX-991, you can do that. So let's say there's a problem here. But now it's important that you need to know that you need to write them in the correct order here. X and Y equal and constant. X and Y equal and constant. Please, it must be in that particular order. You select mode. Again, you select equation. But now you don't choose number 3 or number 4. You choose number 1. This is what you see there. You see, it will be something x plus something y equal to a constant, and it can be another one. So this is going to be 2 variables, a x and a y, so you're going to have 2 displays there, right? So there you'll have that display, you'll enter in there. So what are the numbers you're going to use there? 3, 2, and 12. And here 5, don't forget the negative 4 and the negative 2. So exactly the same way, you enter 3 equal, you enter 2 equal, you enter 12 equal. Then you enter 5 equal, you enter negative 4 equal, you enter negative 2 equal. And that will then be populated. You press a equal and now you get a display. So your first variable, which is x, it tells you x is 2, right? So therefore x, there you get x1 is negative 2. So enter, then you get another one, you get 3. So x is equal to 2, and the other one there would be y equal to 3. That should be a 2 there. Then, and that's how you can solve that. Okay. Now, for those of you who have the standard Casio FX-82ZA Plus, I'm going to show you how you can do that. A little bit different, but you could. So those of you who have this calculator, just listen. And we're going to go through the same procedure here, right? You're going to have that, as what I explained previously. It's exactly the same there. And then you get the other type, right? So they're exactly the same. So we'll just do exactly the same what I explained earlier in the previous slides there. Then let's go with the factor theorem again. If x minus a is a factor of fx, then fa would be 0. What does that mean? If I should have x minus 3, that means x minus 3 would be a factor. If f3, in other words, if I have a negative 3, then f3 will be, then f3 would be 0. The other way, if we determine or we find that fa is 0, it means x minus a would be a factor. If f7, it means x negative 7 would be a factor. If x negative 2, it means x minus, so x plus 2 would be a factor. So let's look at this. We want to show whether x plus 1 or x plus 2 are factors. So first of all, let's get the value of x. X plus 1 equal to 0 means x equal to negative 1. You see a positive and I have a negative there. Now, if I substitute f negative 1 into that and I compute it, I end up with a 10, and 10 is not 0. So my deduction is it is not a factor. Let's take the other one, x plus 2. So I get x equal to negative 2. I substitute f negative 2 in there. Be careful how you do that. And the value is 0. And because the function value there is 0, it means x plus 2 is a factor. Let's look at some possible factors. To find the possible factors here, if we concentrate on the constant, which is the constant value there? That's right, 8 is the constant, right? So what are the factors of 8? That's correct. I can have a 1, a 2, a 4, or 8. And I can either have positives or negatives. Take the other one. Factors of 18. What are they? That's right. 1, 2, 3, 6, 9, 18. And they can either be positive or negative. Okay. Let's look at this one. What's the difference between this one and the other two? Do you notice the difference? That's correct. These two have a coefficient of 1 for the x cube. This one has a coefficient of 2. The coefficient is not 1. So in this case here, if I have a 2, I expect to have fractions in my answer. And what fraction? 2 over 2 will give me halves. I expect halves here. So I'll have factors of 12 would be 1, 2, 3, 4, 6, and 12, either positive or negative. But now I can also have fractions, so it can be 1 over 2. Why not 2 over 2? No, because 2 over 2 is 1. I could have 3 over 2. Why not 4 over 2? Because 4 over 2 is 2. Why not 6 over 2? So I'll only take the odd numbers here. So those are the possible combinations I can use. So this one, because I have 3, I expect to have, that's right, thirds there. What are the factors of 15? Those are the factors of 15. And now I can have 1/3. Not 3/3, because 3/3 will be 1. I could have 5/3, not 15/3, because I have 15 can be divided by 3. Okay, now we're going to show you how you can use your Casio FX-82ZA Plus to solve cubic equations. Right? This is the calculator you're going to use. You enter mode. Right, so there's the equation we're going to try to solve. You enter mode, but in this case you only have 3 options. You choose number 3 table, and then you'll see a fx appear. Now you need to enter x to the third and use alpha with a bracket to get an x. So that's x, and then you now should know how to get a cube. Minus 3, and then again alpha with a bracket to get an x, and then you enter square, negative 6, and then alpha with that bracket key, and then you get x plus 8. Don't enter equal to 0. Right? So you enter this here. Now, When you press the equal sign, you'll see the word start appearing. Now you need to enter a start. Why do you start there? Now the start depends on this here. So what are the factors of 8? 1, 2, 4, and 8. Try not to take the larger one because the memory of this calculator might not be able. So take maybe just instead of 8, rather, so you choose 4. So you say start at -4, and then you end at +4. Right? You could have taken 8, but maybe just go one lower. So that's -4 and 4. Enter. And you enter. Now they ask you for the steps. Now the steps here, because you have a 1x cube, let's make the step the 1. So that you enter a 1. Then you press the equal, and now you'll see a display appear. And you'll have a display like that, which looks like this in reality. Right? Can you see there? -4, -80. Now you need to look at the output. Your output must be 0. So you'll have to scroll down, and you use that blue dongle there to scroll down. So you scroll and look where you see a 0. Can you see there? I've got a 0 next to -2. So in other words, that's already one of your roots. So you scroll to find wherever the fx gives you a 0. There's a 0. So 1, 0 we get by -2. So f -2 was a 0. -2 there gives me a +2 there. You scroll down further and you see by 1 you also have a 0. In other words, x -1 would be my factor. You scroll down further and you see by 4 there's also a, you see, just look where all these zeros are. Just try that again. Just scroll. You must scroll and you focus on the fx, the output values. So they are my 3 factors there, right? Therefore, x is equal to -2, x is equal to 4, and x is equal to 1. I just switch the order around. Doesn't matter. You follow what we do there? No, let's practice that. Just try this over again and see whether you can do that. Let's look at the second example. Here we're going to take one with a coefficient that's not 1. Same procedure. Mode, table. You enter then 2 and you use your alpha, and then you can get those. So you enter the expression there. So you start. Now what would our start be here? Let's look at the 6. I should have 1, 2. Let's not take the 6. Let's take a factor smaller than 6. So we start from -3 to 3. Here we also expect to get halves. And I'll show you how you get the fractions. You won't get it from the calculator, but let's do that. So you enter 3. And if you want to get the fraction, the start there, because you're going to get fractions, you use (5), because you're going to get halves. Your steps are going to be halves. So you need to have (5) there. So for 2, you enter (5). Equal. And this is our display. So now we have to see, and we see already the first value that we have, -3, gives me an output of 0. Right? So in other words, I see the values I'm going to get there. F of -3 is 0. Which means my factor here is x plus 3. I do the other one. I see f 0,5. 0,5 is the one that goes with a 2x. That's a half. That's positive, so I put in -1 there. I scroll down further. I get 2. So this is x -2. And there you've determined your 3 roots. -3, 5, and 0,2. Actually, by scrolling, you actually get those, but I'm just writing to show you the factors that you have there. Let's take another one. So let's skip that. So you enter the negative. So these are we're just skipping the other steps. Now it comes to the starting. What are the factors here? 1, 2, 4, 5, 10, 20. 20 is too big. 10 might be too big. Let's go a little lower. So it's negative. So we take from -5 to, you can even take to 5. I just took it up to 4. Right? Why wouldn't I take 5? Because 5 and a 5, it would be 25. So maybe take a value. But you could take -5 and +5. And here my steps are 1 because I'm no fractions here. So my display here is going to be, so that's what I get on my screen. Now I must scroll down. See, there's no zeros here. So you must scroll until you will find your zeros. So the first 0 you get by -2. So in other words, here the factor would be x plus 2. You scroll down, you get a 5. So that will be x negative 5. You scroll down further, right, and you see you didn't get another one. There's no others. That means one of your roots is repeated, right? So in other words, it can be 2. I can't have another 5 because 5 times 5 times 2 won't give me my 20. So it has to be another 2, not another 5. So this one only has 2 distinct roots, 2 different roots. X equal to 2 is actually repeated. That's my 3 roots. X equal to 2, x equal to 2, x equal to 5. But there are 2 different roots, 2 and 5. They have just written all 3 down, but they're exactly the same. Now, let's look at this one. Here, again, my starting. So important is just to know your start. You won't take 12, so rather start with negative 6 and 6, right? And your steps are, that's right, preferably, if you're not sure, just choose a step of 1. So there's my values, and I display, right? And now I start, you see the only value I get is x. If I just, there's no others in my table on my calculator. The only one that pops up there would be 6, right? So this one only has one real root. The other roots are non-real. The same way, I'd like you to try this, and then you can verify your answers afterwards. Thank you very much. You can see this was our display that we had there. And if we scroll down, you know, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, you know, until you get to 6. The last one there actually worked. So there's no others that would have worked.